today's video is the introduction to our next unit, which is going to deal with polynomials. So first, let's define what a polynomial is. It's an expression which is the sum of terms of the form AXK, where x is a positive integer. Sorry, k is a positive integer, not x. K is a positive integer. K is a positive integer. So when you have this, they're all going to be of the form AXK. A is going to be some number. It's going to be the coefficient. X is always going to stay x. And then K is going to be the exponent, and it's going to be positive. So standard form you're going to hear about. We're going to make sure that these polynomials are in standard form. And what that means is that the terms are placed in descending order. From largest degree to smallest. And the degree, which we're going to look a little bit more into in a second, is actually the exponent. Largest degree to smallest degree. So let's kind of look at what this means. So a polynomial in standard form is going to look something like this. Let's say I have 3x to the fourth plus 2x to the third minus 5x squared plus 7x plus 4. So we're going to look at some of these parts. So this 3 in the front, that is the leading coefficient. It makes sense because it's leading the train. You notice that these are in standard form. It's the exponents or the degree is in descending order. 4, 3, 2, this would be 1, and this would actually have a degree of 0 because x to the 0 would make it 1. Okay, so those are all the degree. And then this guy at the end, the caboose of the train, that's going to be our constant. Okay, so that's what these polynomials are going to look like. It's a bunch of terms. Each one of these is a term, and it's separated by addition or subtraction. So we are going to have to classify these polynomials by their terms. Okay, so monomial, that's what I need to say, is a polynomial with one term. So an example might be 2x. I want to go back and mention in standard form because I don't know if I said it clearly. In standard form, it is very, very, very important, like the definition says, that those exponents are in descending order. And you can notice in this example back up at the top, they are in descending order. 4, 3, 2, 1, 0. Okay. So monomial is one term. Binomial, by the prefix bi, just like a bicycle has 2 wheels, is going to be a polynomial with 2 terms. So an example of that might be 2x plus 1. Okay, and you're going to have to memorize these. Some of these are easier, like tri. We know what tri means. Triangle has 3 sides. Triangle has 3 angles. A tricycle has 3 wheels. So a trinomial is going to be a polynomial with 3 terms. And an example of that might be 2x squared plus x plus 1. And you'll notice that when I'm writing these, I'm writing them in standard form. And the last one, poly means many, the prefix poly. So this is going to have, it's going to be a polynomial with 4 or more terms. So an example of this, like the one you saw in standard form, might be 2x to the fourth plus x to the third plus 2x squared plus x plus 1. So it's more than 4. We call it a polynomial. Okay, so we're going to classify it by its terms, and we're also going to classify these by the degree. Okay, so when we talk about classifying them with the degree is the exponent. So when you have a polynomial like this example up here, we want the highest degree. Okay, so this example here, it would have been a degree of 4 because 4 is the highest degree that there is out of all of them. So first one is constant. This is a term with a degree of 0. So an example might be -10. And the reason that it has a degree of 0 is because this could be -10x to the 0. Again, we know that x to the 0 is 1, so that would just be -10 times 1, which is -10. So, linear. This is a term with a degree of 2. An example might be, oh, the degree of 1. I'm sorry, I'm way ahead of myself. Linear has a degree of 1. An example might be 3x plus 1. And it makes sense because if you remember when we did lines, linear, they all had the form. This looks like the equation of a line. So that might be a way for you to remember linear. The next one is quadratic. Quadratic is a term with a degree of 2. So an example might be -2x squared. Quadratic, you could remember, the only thing I got for you, maybe there's 2 a's, so it's a degree of 2. It's hard. You're going to have to figure out a way to memorize these. Cubic might not be so bad. We've talked about cubic before. You know that like volume is in cubic inches, feet, or whatever the measurement is. So this, of course, is a term with a degree of 2. An example might be, I said 2 again. It's a degree of 3. I need to get with it here. So cubic is a term with a degree of 3, and an example could be just x to the x cubed. All right, got 2 more. We have quartic, and if you can guess how this is going, this is going to be a term with a degree of 4. The way I remember this is that it sounds a little bit like quarter, and a quarter is a fourth, so there's 4 quarters and a dollar. Just any way to help you out in memorizing these, because you will need to know these words. An example might be 8x to the fourth. And the last and final one, quintic, this is a term with a degree of 5. And an example of this could be -7x to the fifth. All right, so that is it for definitions. If you flip your page over, there's a couple different examples that we're going to look at. This first part is a chart that kind of gives some examples, and you have to classify what the degree is, classify it by the degree, and then classify it by the term. So we're going to kind of mix all those definitions from the front. I am going to number these. Again, I'm going to do a couple examples, and the rest of this back page that I don't finish on this video is you're responsible to finish at home before class. So the first one, 7. This has a degree of 0. Because it has a degree of 0, it is a constant, and we've heard that word before. And it only has one term. It's just by itself, so it's a monomial. Monomial. That one's hard to say. Okay, so 2 and 3 you're going to do. I'm going to do 4. If we look, we can see the highest degree here is this 2, right? There's a 2 and a 1. So 2 is higher, so this is a degree of 2. Because it has a degree of 2, it's quadratic. And again, it is a binomial, bi meaning 2. Okay, so finish that chart up for homework, and then we're going to get to the bottom. Couple things that you have to remember. When we are adding and subtracting these polynomials, you can only combine like terms. And that should sound familiar because that is true in other areas of math that you've seen. You can only combine things that are alike. And if you are subtracting two polynomials, you must first distribute the negative sign to all the terms in the second set of parentheses. That is one of the most missed things in this unit. And you'll see what I mean when I do example 2. So first thing, we're going to add. So I can just drop the parentheses, and I have x squared minus 7 plus 2x squared plus 2. So now I can combine my like terms. I have an x squared here, and I have a 2x squared here. Now remember, we're adding and subtracting. We're not multiplying, so we're not changing the exponents like we did in the last unit. We're just combining our terms. So I have 1x squared, and I have 2x squared, so I have a total of 3x squared. And then I could look at my constants. I have a negative 7 and a positive 2, so I have a negative 5. So my simplified, it's a binomial now, is 3x squared minus 5. Okay, so this is where the negative comes in. If you notice, I'm going to erase this a little bit so I can. If you notice, now we are subtracting. We must first distribute this negative to all of the terms inside there. So I have 12x to the third plus 10 minus 18x cubed plus 3x squared minus 6. Okay, so I had to distribute that negative. Please don't forget to do that because that is a very missed question. Okay, well now I can combine my like terms. I have 2 that are cubed. So I have 12x cubed, and I have a 18x cubed. So I'm going to combine them. 12 minus 18 gives me a negative 6x cubed. All right, now let's look for my x squared term. I have just this little baby 3x squared. I don't have anything to combine him with, so that's just going to become plus 3x squared. And then finally, I have my constants. I have a 10 here. I have a 6 here. 10 minus 6 is 4. So this is my simplified trinomial. All right, it is your responsibility to complete the chart on the top and complete examples 3, 4, and 5 when you come back to school. And we'll practice with this